Dear students, in today's presentation, we are going to see another problem from the Taylor's two-life equation from the module 3. The question is, analyze the life of tool which is used for rough turning, which gives a tool life of 1 hour at cutting speed of 30 meter per minute. What will be the life of tool when it is used at the same cutting speed for finishing operation, which means that finishing operation. So they have given an n value is equal to 0.125 for rough cut and n is equal to 0.1 for finish cut. So the same question was asked in the June-July 2024 VTU examination. So here, if you analyze this problem, you can able to see there are two different operations. One is rough turning operation and finish turning operation. For rough turning, they have given an cutting speed, tool life, n value, everything they have given. And for the finish turn, they have given an n value alone. So we need to find out the cutting speed which is required to complete the finishing turn for this problem. So now the given data. So as I said, here we have a two different condition. One is rough turning and finish turning. For rough turning, the cutting speed, which is represented as V, R is equal to 30 meter per minute. T R, which is nothing but time, is equal to 1 hour. N R is equal to 0.125. And the same for finish turn, which is condition 2. So in the problem they have given the cutting speed will be same for both rough and finish turn cycle. So Vf, which is nothing but cutting speed, is equal to 30 meter per minute for second condition also, and Nr is equal to 0.13. Okay. So now here from this problem we need to find out the tool life of an finish cut or finishing operation, finishing turn. So the formulas what we are going to use is V into T to the power n is equal to C. So here V is equal to cutting speed, T is equal to tool life, C is equal to constant and n is equal to constant, that we have seen in the previous presentation videos. Now here, by using the rough cut or rough turning process, we need to identify the constant value C. Then only we can able to find out the tool life basically for the finish turn. So the formula what we are going to use here is VR TR to the power n is equal to C. So here VR is 30, which is given in the problem, which means cutting speed, and TR, which is nothing but time or tool life, so which is 1 hour, and n is equal to 0.125, which is given in the problem, is equal to C. Now if I simplify this, I can able to find out the value of C, which is 30. And the next one, finish cut or finishing turning. So for this finish turn, I am going to use the same problem, but I am going to use the finishing turn or finishing operations data. So Vf Tf to the power n is equal to C. And in the question they have given that the cutting speed will be same for both rough cut and finish cut operations. So here instead of Vf, which is nothing but cutting speed, I can use 30, and Tf to the power n, which is given in the problem 0.1, is equal to the C value which is we have given in the previous step, which is 30. Now from this we need to find out the tool life. So if I want, now here what I am going to do is I am going to keep the known terms and unknown terms on the either side. So which means that I am going to keep the unknown terms on the left side and I am going to bring all the known terms to the right side. So if I do that, it will become 30 divided by 30. So it will become 1. Then the next step will be Tf to the power 0.1 is equal to 1. Now if I want to if I want to find out this Tf, I need to bring this power to other side. So if I do that, then the next step will become Tf is equal to 1 to the power 1 by 0.1. So if I simplify this, I will be getting an 1 answer, which means that for the speed of 30 meter per minute for finishing term or finishing operations or finish cut, the tool life will be also 1 hour. So that is the final answer. Thank you.